This is powering smart devices using Internet of Things. My name's Sean Daggins. I am an AI edge engineer, which is a weird sort of title, but basically, my primary focus is on artificial intelligence, data systems, and putting things out onto IoT devices and out on the edge. And with me today is the illustrious Josh Handel, and I'll let him introduce himself.
I don't know that I'm illustrious. I'm present. I'm the director of Agile Services here at Catapult, so I focus on how we deliver really value across the company and how we help our clients deliver value. And I'm a big old IoT nerd. Not in this project. I've built robots to test various very edge case nerdy things. And so Sid was like, hey, you should help Sean with this because you like doing things with IoT devices. So
yeah, and sadly, we do not have the sword bot because that's what it is. It's a sword bot. Yes,
yeah,
you heard that correctly.
we could not find a way to take my low-level C code and integrate it with Event Hub fast enough to make it worthwhile.
There you go.
Maybe next time.
Maybe next time. But what we are going to be talking about today is, so this is what's on our agenda. We're going to talk a little bit about, what Azure brings to the table from the IoT perspective, from an architecture, from a way they've been sort of setting the direction. And, Josh and I will talk a little bit about that. We're going to talk about AI at the edge. So if you've been following along with the tracks today, we've seen basically ML ops was the what we were just basically witnessing and onto, and this sort of takes it a little bit further and says, hey, why don't we just deploy that machine model all the way out to a Raspberry Pi? Because why not, right? And then we're going to talk about digital twins, what that is, what it means for your business. Discuss a little bit about the art of the possible, like what so a lot of our focus here is on the data maturity model, and so what does it mean when you start actually kind of getting control of that, and what you can do and where you can move with that, and then we're going to look at some very specific use cases. Using a product from Microsoft called IoT Central, where we'll be able to do a little bit of deep diving into what the data actually looks like and how you can manage that and where that fits. So let's talk a little bit about Azure IoT, and Josh, let's just talk about IoT in general. Like, it's been around for 20 years, right? I mean, like the first versions of it were like a Cook machine or a toaster or things like that. So it's not a new technology, but why do you think it's something that Microsoft is really putting a lot of effort into now? What's changed?
Well, I think what's really changed is the accessibility to network and the cost of compute, if you will. So, I mean, we did this napkin math, right? So my first computer was an Atari 800. It was a 1.5 megahertz machine, and it cost in today's dollars $2,500. That was 1984, 1985, something like that.
Yeah.
It might maybe a little earlier, but now you can get a Raspberry Pi that is a 1 and change gigahertz multi-core, 4 gigs of RAM, put an SSD on it, has Wi-Fi, Bluetooth, an Ethernet port, and a whole stack of pins for integrating custom sensors for between $30 and $60, depending on kind of what variation of that you decide to get together, Pi 3 or Pi 4. So this idea that I can put something relatively powerful for almost no money, kind of anywhere in my environment, and then with internet being kind of so pervasive, now I can sense things anywhere, and the cost of doing that is cheap. And the reality is this only works if you can put a lot of devices everywhere. And you can only put a lot of devices everywhere if the devices are demonstrably inexpensive, right?
Right, exactly. Yeah, so like for instance, this is a Raspberry Pi 3, And I can pick one of these guys up for like $40 now, and it's got more processing power than the moon lander, right? So it's like it's amazing, like what is available and what's out there. And yeah, I agree with the faster networks, with the cloud capability, with 5G on the horizon. Like 5G has actually been built specifically to handle IoT devices. So more than just phone communication, it's designed to handle IoT devices. So
Right.
there's definitely a movement, not only from Microsoft, but just from technology in general, to take that sort of processing that we've been doing on the cloud, and the sort of intelligence we've been doing on the cloud, and push that further down, closer to what I consider like the source of data and all of
Yeah,
that.
like your network gets easier too. So IoT is in the thoughts all the way back when IP6 was being thought of, right?
Yeah.
So the whole reason the IP6 range was it's big enough to give an IP address to every atom in the universe, I believe, or something ridiculous like that. Basically, it's some obscenely long, number. But the intent is that they want to be able to not make network ever be a bottleneck to pervasive compute.
Right. Devices everywhere, basically. And so if we take this back to where Azure is right now, so with the Azure tools, Azure's, and basically Microsoft has really brought a sort of principled method of working with IoT, and they've structured a number of tools around it, and those tools are highly integratable, meaning like you can integrate them with a lot of different data systems, and they're fairly simple and easy to get up and running. But from the big picture side of things, basically we've got things, and this really can be almost anything. It could be a laptop, it could be your mobile phone, it can be your car, it can be industrial equipment. What we can instrument these days is very, very broad. So if there's some place where you think, oh, I want to be able to collect data on this thing, there is probably some microcontroller unit, or some type of device that we can put on that thing, or even watch that thing. Even really old equipment, you can basically use a camera, with some smart vision AI behind it, to watch that device for failure. So things is an incredibly broad category. And what Microsoft has basically brought together is, IoT Hub and IoT Central, event hubs, and some of these tools to basically capture that telemetry and that data off of it, so that you as an organization can take that data and build insights off of it. And then of course from that insights we can start creating actions, meaning like it's great that I've discovered new things. And one of the things we were talking about earlier, one of the earlier conversations throughout the day, was when these trucks started basically discovering that they were putting telemetry on the truck to watch and monitor the refrigeration. They could figure out that, hey, after a while, we know that this is going to fail because the temperature starts to drop in a very, clearly defined way. Well, now they got something to look for, right? So now there's an insight there, and now they can look at that. And when they see that that's starting to happen on that truck, that refrigeration system is about to fail, instead of letting it fail and possibly ruining whatever's actually the cargo for that vehicle, they can pull it in for maintenance. They can do those changes and fixes, and they can get back out on the road without losing, the actual, cargo of the truck.
There's
So
actually a machine. So for manufacturing, especially for aerospace manufacturing, they do this for the machines that cut the metal. So you have a chunk of titanium that's potentially thousands of dollars of titanium, and as the tool is cutting, that has causes vibrations in the machine. They actually detect the vibrations and can use AI to go, oh, we're about to get into a situation that's bad for the tool, bad for the material, whatever, and can either modulate the cut or change or just stop the cut and air out and say, oh, something is,
yeah,
maybe the tool is dull or whatever. So they can actually do that in, kind of hundreds of a second or thousands of a second sampling, but you only do that by having this external compute sensor device with this model sitting on it.
exactly. Yeah, exactly. And so that kind of functionality, that kind of approach, to creating more intelligent devices, and that's one of the focus of our talk today, is this idea of I've got a suite of tools here that are meant to help me follow along with a very similar process like what we were talking about on the ML ops process, which is that I'm gathering data. I am likely putting analysis in place. And maybe that's just very simple business logic. Maybe I'm just doing some queries, and when something shows up in a query, I act on it. But maybe I do need something that's more complex, like a machine learning model or an AI that needs to sit down there on the device itself. And so that's where what we've got here is our big picture of things and insights and actions are just some of the tools that are available. And I can tell you from experience that, you don't have to have all of these things. You can easily just go from IoT Hub to Azure Storage down here, and then you can pick that up and do things with your machine learning model, and you can package that model up and push it right back to the device through a container registry or something like that. And of course, there's built-in security systems. So you've got security that's basically making sure that your device is going to be tampered with, that you can lock that up with an actual certificate, so that you're saying, like, look, this is one of my devices. I've deployed it. I trust it. I'm going to allow it. I'm going to accept telemetry on it. As well as the whole entire suite of data processing tools as well. So we can store data on, we've obviously have like Azure Synapse here and Azure Cosmos DB, but you can also store the data on Azure SQL. You could, PostgreSQL. There's a number of different tools that you can store and work with that data on. So here's the fun part. I know. So Josh, you've had a little bit of experience of pushing models down onto a Raspberry Pi device. So what, for you, what were sort of the complications, and what was the, because that was a little while ago, and it's improved a little bit since then, right?
It actually wasn't that bad. There's some initial configuration on the Pi, basically to register it in your IoT hub, and then once you do that, it's pretty straightforward. I think it was most eye-opening, I guess, maybe is the best way to think about this, is like you think like, well, how am I interacting with it? And what actually happens is very interesting. So basically, you configure your device, and it at least with the Raspberry Pi or with those kinds of devices, it may be different when you're talking with a true microcontroller, like some of the Azure Sphere microcontrollers. But what actually happens is they push down a container, and you actually run a Docker container with whatever your integration to IoT Hub is. And so then when you write your on-device code, that on-device code then talks to the container through web calls, through API calls. So it's like calling in any web service in the world. It just happens to be the web service as a container on your device.
Yeah.
So your code can be, referencing the other example, could be low-level C that is reading. In the case of the thing we were talking about, I was reading pressure data 7,500 times a second, and so I had to write really, really low-level C. I was like literally counting, it's 170 millionths of a second between samples, right, or 130 millionths of a second between samples. Right, but I can do that low-level C, and then I can ship that data to the container, and the container takes care of its side of the house, right? And being multi-core, that's not necessarily a problem. But that was the big eye opener. Like, well, how is this Pi or this whatever interacting with the cloud? Do I have to write special APIs? Like, no, it's a container. It's running a web service. You get a port to call, and then you write your code, and your code calls that port, and then IoT Hub and your whatever logic you had associated with it is kind of concatenated inside that container.
Yeah, absolutely. So it's not a super complicated process. And I think that's what really kind of makes this interesting, is that I can separate out, right, a certain amount of like the code that I'm writing, and what I need to do from a device side, right? So I can focus on that lower level telemetry gathering type of code, and I can use like for instance, Raspberry Pi uses a lot of hats, and so this is a, or if you're familiar with Arduino, it's a shield. It's basically a thing that sits on top of the Raspberry Pi, and allows me to connect to a lot of different devices. And I can use some very specific Python libraries to gather that telemetry. Well, I can do that on the device, and then I can actually have my IoT Edge module that sits on the device, just like what Josh described, as an API. So it's almost like I'm calling a local web server of some kind and saying, hey, here's some data that I just gathered. Why don't you do some processing on it? And then why don't you send that processing back up to IoT Hub, or send it to me and I'll do some analysis on it. So it's that kind of capability. And even from the microcontroller unit, they are working on getting those containers down small enough so that you can do that sort of thing on the microcontroller unit, and even on larger things. Now, IoT Edge doesn't do this right now, but there is actually some libraries and some things that say, hey, let's actually deploy Kubernetes out there, right? So I can have that redundancy. I can build up a cluster, and I can have pods that are now those machine learning modules. And I can have those going out there. And if one of them fails for some reason, then Kubernetes will kick it up and get the other one up and going. And the IoT Edge side, so IoT Hub, has a lot of tools that are available for monitoring the health of those devices and of those modules that you've put out there to make sure that they're up and running and they continue to function the way that you would expect. So that's the capability of being able to push models down and being able to push that intelligence down to like more devices. Opens up a whole new kind of idea and a whole new concept. And this is the concept of digital twinning. And it's the idea that I can take a physical building or a facility or something like that, and I can digitize it in the cloud space and in the cloud world. So there's a modeling language that's basically built around that, with the idea of taking like a stadium or something, and now having this sports arena or the stadium in a digital format where I can now run models on it. And I can monitor it. So a lot of the things that we've talked about from a DevOps standpoint, like that visibility and that reliability and the availability, you can move those things that you sort of like expect from a digital device, and you can start applying those same sort of concepts in the physical world. So I don't know, Josh, have you seen any like real world examples of this recently?
So I mean, the biggest one I can think of, and it's a pretty big one, is and it's not hosted in Azure. This is a generic concept, not Azure specific. Would be Tesla's current how they train. So they completely rewrote they're in the middle of completely rewriting their full self driving to be trained off of trying to remember the name. They had a whole new name for it, but basically they created digital twins of all their vehicles, and they take all of the telemetry data of their millions of cars that are driving around, and they use all of that telemetry data to create a fake world for the AI to learn how to drive in. And they give the AI digital twins of the actual cars. So it's not just a digital twin of the car, it's a digital twin of the car and a digital twin of all of the traffic scenarios they want to train the car to handle.
Yeah, it's I mean, I don't know if there's any science fiction fans out there, but all those cyberpunk things that we kind of grew up like reading about, virtual worlds and interacting with those virtual worlds, is really kind of starting to come into reality. I've been looking around and seeing, okay, who's putting this in place, and a lot of it's going into like smart facilities, specifically for building maintenance and being able to connect up your IoT telemetry in those areas and test it, and then I can test my devices before they ever even go out to the actual physical location, right? So if I need to do device upgrades, or I need to, if I need to see what's going to be the effect of having this device in this physical space, I can get some feedback and some testing that's related to that. So this is yet another, this is a newer Microsoft project that's just, that's pretty much come out of preview that does give you these kind of capabilities, and it does mix really well in with the whole IoT suite. There is a concept of like device shadows, and I think that that's what AWS calls them. Microsoft also calls them device twins, and it's the idea that I can have a device that's out on a location, and I can actually have a copy of that in IoT Hub or available to me through some other application where I can set parameters and make changes and do things like that. And we'll see a little bit of that, but it doesn't quite, I think, meet like the kind of coolness factor that the ability to create a digital twin of like a physical location or a product like a like a Tesla, or even a consumer product. If I had a consumer product, an IoT device of some kind, I could digital twin it in like a refrigerator or something like that. So there's that's coming down the line, and it's a very useful tool for doing your testing, doing product development, and getting insights into real world devices and what's going on with them. So we talked a little bit. I got the dreaded page that goes by too fast. Let me. I'm going to cheat and just go stop it and fix it real quick. Or actually, we'll just go ahead. We'll go back for a minute. So a little bit of what we were going to talk about is the art of the possible, and that's what's on the screen. But this screen's going to go by really fast. But Josh and I are going to talk about it anyway. It doesn't matter. We don't need a screen for that, right? So we know that there's a number of like use cases for IoT, IoT Edge, and a lot of those are around industry and government and medical. And so Josh, real quick, like what are you right now from an innovation standpoint? Where do you see people who are working in like small and local government or retail? Where do you see them getting like the most wins out of this kind of technology?
So I think for state and local government, this is finally an opportunity to instrument your area with like a factory might instrument their business. So that's utilities instrumentation, looking for leaks, or looking for quote unquote bad behavior. It could be as well. Along with that, you could look at traffic flow patterns. You could look at consumption of resources. There's basically anywhere that you are currently blind on how things are working. This gives you the chance to bring something in to be able to monitor that. You could put up some cameras, tie them to Raspberry Pis, and as they mentioned as a previous example, count people at a crosswalk.
Yeah.
Or count vehicles driving through an area without having to put up the road stompy things. And or you could leaks. I think that was it a $1.5 billion a year problem with leaks in Los
Yes.
Angeles?
Los Angeles.
So, I mean, that's with a B. That's a big number. That's a big
Yeah.
problem. In electrical, depending on your area, if you're a big county, if you're a huge county in Texas, you might want to be able to instrument your electrical grid. There's some old tricks farmers use where they have a well that needs power. They wind a bunch of copper cable under some high voltage lines. Didn't know if you knew this, but the high voltage lines will in fact create a current in a wind of copper cable, and they can get enough current to run a pump out in the middle of nowhere. Electric companies don't like that, and so they literally generally they have to do is like drive the line to find it because it's small enough for loss. But if you instrument it properly, you can detect those things, especially if you have AI helping you observe those kinds of possible alterations in your lines. It's really the space right now is it's in a learning stage. So it's about how do I learn more about my constituents and how they use systems, whether it's parks, could be flood zones, right? You could basically, like, if there's a low water crossing, you could put a camera on it and have some AI that says, hey, I will alert when I know that this is in a flood condition. And maybe that's cheaper and faster than putting industrial switches and sensors and worrying there's a much simpler, lower, challenge thing to do, right?
Right.
Potentially significantly cheaper too, because industrial switches and getting all that tied into the grid and getting that sensor data back to somewhere, actually that's really expensive, right? But a weatherproof box and a cell phone signal is really cheap
It
comparatively,
is.
honestly.
Yeah.
Um,
It's dirt cheap. And
uh,
I think so. I think, and so that brings up a good point. We're going to talk about a little bit of that at the end of the presentation, but is one of the things that we do are these innovation workshops, right? Where we can like basically bring you in and look at, what's your situation, what are some problems that you need solving, and we have unique ways of basically going about and doing some discovery and helping to determine what's the right kind of technology for solving those things. And for instance, it doesn't. We've covered a lot of like really big kind of, some of the architecture we were talking about is, the sort of thing that you would need if I've got 250 wells, for mineral gathering that are, scattered across the state, and I need telemetry on all these things, and I need to capture it in some way. Well, that's where, IoT Hub really comes into play, and it's great for that. But I can also, say that, look, if you're like a small, company, and you're thinking, well, look, I've got like an art installation company. That's what we do, and we have 3 trucks, and I've got, 6 people who are certified in hanging art. Is there really like a product that's going to help me track my trucks, track, my gas mileage for the, it like, isn't that sort of overkill? And I think that's where IoT Central comes in. And so just to talk a little bit about this, so this is a SaaS product. So this is actually a software as a service product that Microsoft has created, as one of their suite of tools for working with IoT. And I really like this product for the, people who are interested in seeing what can IoT do for me, right? It really doesn't, you're not looking at a lot of upfront costs to get this stood up. And as a matter of fact, I'm going to go ahead. So I've got some images here. I'm
so
going to
real
go
quick,
ahead.
to jump over, I was going to
Yeah.
say, want to go back to the slide for a second.
Okay.
I
Yeah.
wanted to mention that the four pictures he's got there, that's 4 of the out of the box um, solutions they have. So they've got a bunch of solutions for state and local government. They have a bunch of solutions for retail. They have a bunch of solutions for healthcare, and then they have what's the 4th
So
category they have solution?
we have energy. So
Energy.
we have
That's the
like
4th one.
solar,
Yeah.
yeah, solar panel, and state, and I'll kind of touch on those apps a little bit. But yeah, and we're not talking like a 6 months to get something up and rolling before you actually see telemetry. We're talking like within a week, right? And so, with the thought in mind that this is a more of a playground that you can kind of continue to build upon. So if you are that sort of state and local government or a small organization, you really just kind of want to put your foot in and see, okay, what can we do with IT? What is like the possible things? This to me is a really good place to start. And by no means do I want to say that this is a toy. It is not. This is a fully, amazing production level product. I just think like, if you're Merck and you've got like, 250 oil tankers and you need to basically track that, this isn't the product for you. But if you've got a smaller business and you want to be able to track cars, or you want to be like, a good example is, a friend of mine actually rents golf carts in Florida. And so, one of the things I'm talking to him about is telemetry, like, hey, why don't you track the golf carts and, all that kind of stuff. And so, and this would be a good product for somebody like that, because it's a little smaller, it's a little bit more contained. And so, without talking about, let me just go in and actually show you a little bit about like what we can do with it, right? So this is my dashboard for IoT Central, and I hope everybody can see it okay. I'm going to go ahead and try and make it a little bit bigger here. I guess maybe not. Can everybody see it all right? I just want to make sure, because my screen is not exactly the.
You could risk zooming your browser.
Yeah, let's zoom in a little bit. I don't know why I'm pushing the buttons to zoom and it's not zooming. So let's see. There we go. Okay, now it is. All right. So is that a little better? Okay. So this is basically the admin for IoT. And let me jump back because we're actually in the app. So let's go back out to home and basically talk a little bit through what you see. And you can get this to going to apps.azureiotcentral.com. And it will give you kind of a walkthrough and show you like what are some of the things that are available. And just like Josh was saying, out of the box, we get a number of things that we could basically get up and rolling. Connected logistics, digital distribution, in-store analytics, condition monitoring, in-store analytics checkout, like, you know, what that actually looks like, smart inventory management, micro fulfillment center, video analytics, object detection. Obviously, some of these things would require devices, but there's a really nice device catalog that you can go to, and you can just buy things off the shelf and they automatically integrate into IoT Central, making setup of these, you know, very far easier than it has been in the past.
So if I
So
can give an example of when you might use, let's say, in-store analytics for checkout. This is a real scenario. So I believe it's JJ Crew. They do real-time staffing. And they do that off of the analytics that come off of their registers. So they will literally be like, you're on break for the next hour. Okay. And we expect you to come back, you know, and you know, so they will basically do on calls for portions of their staff and do real time callbacks and stuff based on velocity metrics and other analytics that come out of their store analytics. So while they're not using this tool exactly, it's a real example where an industry is, you're giving you a chance, depending on your size, you're getting a chance to do something that a billion-dollar retailer is doing.
yeah. Yeah, and just from a simple sort of grocery store standpoint, it's like, hey, you know, we need more people on the checkout. We need fewer people in the butcher shop, right? It's a good way of sort of that is an excellent use case for that. And so along with retail, we've also got energy. So we've got a couple here, you know, solar panel monitoring. There's a lot of small solar panel shops. I know because they come and knock on my door all the time, looking, you know, to basically get in on the solar panel business. So, you know, solar panel, smart meter monitoring, from the government standpoint, water quality monitoring, water consumption monitoring. So that's a big one from the California standpoint, and obviously like connected waste management, right? So these are all problems that are ideal for your small for your local government, right? Is managing those things. And then from a healthcare standpoint, there's the continuous patient monitoring, right? So that's where you bring in those IMT devices, right? The Internet of Medical, you know, things, where you can monitor your patients and you can monitor, you know, the doctor can get, you know, immediate feedback. The administrators and nurses can get immediate feedback, and so that's where, you know, these kind of applications really are helpful for those particular sectors. So let me dive a little bit in. I've got a little, you know, fake app that I've put together here.
And as
I'll
you
come over
notice, you
here.
clicked on custom, which is
I
always
did.
available.
Yeah, you can always create a
Always
custom,
build your own thing.
and that's what this is. So this is a custom app. I just created, you know, a really quick, you know, custom application. And the premise here is that, you know, I've got a small company, and I've got about 4 vending machines that are spread out around Texas, and these are very specialized vending machines that I have people who keep filled with cupcakes. So you can go to this vending machine and you can buy a cupcake. And so there's a number of things that we kind of want to monitor on it. You know, we want to see sales. We want to make sure that the temperature stays in the right range. We don't want it too cold, you know, or to get too hot. And so there's some things that we're doing on that. And so I've got a dashboard here that I've created that kind of, you know, is for, you know, a general operator like myself, kind of want to keeps track of what's going on. And I've got telemetry coming in, and so it's giving me like this very nice quick view where I can see, okay, what is my, you know, what's my sales count in the last week? And I can see in Dallas that I've sold 600. Fort Worth's only sold 375. That's because it's a little bit of a newer vending machine. My Houston 517, and then Austin I'm at 562, and I can kind of look at my temperature ratings here and say, oh, that's a little higher than I really want. I really want my temperature to stay closer in here, so I might need to do some things to like fix that. But now that I got the data, I've got that insight into it, and so if you went to the data telemetry discussion earlier today, that's where this kind of telemetry comes into play, where you can actually instrument it and see, from a graph, viewpoint what you're seeing. So device setup is pretty simple. Whenever I'm in here, basically I create a device template, and I've got two here. I've got version it. This was my first device template that I created. And I've got my very specific, telemetry type data that I'm gathering here. And I have some cloud properties that are associated with it. So I've got my fridge temperature that I can set from the cloud. And then I can kind of view what those properties look like from here as well. And I can put my addressing in here too. So if I need to set where my address of my machine is, I can set that up. So this lets me basically set up the skeleton of what an individual device looks like. And when I go into my devices, you can see now that I've got 4 here. Fort Worth's my newest one, and yeah, and Houston. So I've got Houston here. And so now I've got my very specific, this is for my Houston device. I've got an actual, kind of heads up that I can look at where I can see what was my last reported temperature, what's my cake inventory purchase, last purchased, and I've got my waiting for data, which this would be like, if I filled it. Now I don't actually have the filling process in place yet, but that is something that I could do at some point. And from here, I've got, this is my actual location, so I can set it. If I need to change that, I could. I could come down here and say, you know what, I may want to change this down to like 8, and then I can save that. And so now I've got a range that I want to try and stay at. I can also come over here and look at my raw data. So this is my actual telemetry data coming in. I can see what that looks like from here, which is, not incredibly interesting, but it could be more advanced and more detailed if I needed more things. I can group devices together. So in this particular case, I've got them grouped by their particular versions, and I can have different kinds of devices. Now there's a hitch to that, in that it on the back end it treats all telemetry pretty much the same. But if I wanted to track my trucks and do some other things, I could actually store some of that telemetry here. I can put rules in place. For instance, if the fridge temperature starts to get out of range, I can actually have it send me an email, right? So I can say, hey, if this is less than or greater than any of these values, I want you to notify me and the team that this has happened, because it's likely that something's gone wrong, right? I have some built-in real-time analytics capabilities, which is pretty cool. I can kind of come over here. I can pick one of my device groups. I can say, you know what, I really kind of want to see, inventory purchase. That's what I care the most about. And I'm going to group that by ID, and then I'm going to do analysis. And look at that. Oh my gosh, I get all this crazy stuff. But I can minimize that, and I can say, okay, I just want to see Houston, and I want to kind of see where I'm at with that. And then I also have a little bit of ability here to kind of like, I could download this, right? I could basically download this data onto my local system if I want to do some things with Excel. And I can also create a table, right? So I can see what this data looks like from a table perspective. Now, the very cool thing about IoT Central is that I have the capability of integrating it with some more powerful back-end tools. So it's a good starting place, and there's definitely some very cool things that I can do just with the device, the application itself. But if I want to, I can actually start exporting my data in multiple ways. I can show you here like the number of destinations that we actually have. I can put it in blob storage, so that means I can basically store it as flat files that I can use for analysis later. I have event hubs. Now, event hubs are very much like, big and powerful like IoT Central. It's used to accepting a whole lot of events. It stores those events, and I can build and trigger things off of those events, as well as collect data from those events. And we'll go into a little bit of that Same thing with my storage, my service bus. So this is your traditional enterprise integration message queue, right? Where I'm going to drop things onto a message queue. I'm going to have some other application that's going to pick up that telemetry data. It's going to do something with it, further down the line. Same thing with a bus topic. That's more of my publisher subscriber. So I can now push it up to a topic, and a number of subscribers that are subscribed to that topic can get that and say, okay, yeah, I'm interested in vendor cupcake data. Let me go grab that and see what I can do with it. Webhook is another thing. So if I need to just basically push this off to another API, like if I were integrating with AWS or Google Cloud Services, I would set up my API on that side so that I could just basically connect to this and send that telemetry data directly to one of those other cloud destinations. Now, real quick, I will jump into what this kind of looks like from a telemetry standpoint, and what we're gathering on here. So this is some of that back-end stuff that we looked at on that original slide when we were looking at the IoT architecture is here, right? So I've got my event hubs that's set up. I've also got, this is my IoT Central application. So this is actually it in the Azure world. You notice that it's just this service. There's a few things that I can kind of do with it from here, but I don't have a lot of control. They do that on purpose. It's mainly because it's a SaaS application. It manages the data and everything for me. I don't have to do a lot with it. I've got my blob storage here, so I can actually store my data in here. And I can go into my blob storage, and I've got my telemetry data. And if I wanted to do something like some data science or something like that on the kind of data that I'm gathering, this would be a good place for me to point my data engineers, my data analysts to. They could take that data and start doing, maybe machine learning on it, or maybe just some really simple regression type models where they're looking and trying to make some guesses about what's inventory need to look like next week or some things like that, which is very cool. And as well as that, I have one thing that's called my stream analytics job. Now, this is where you can actually kind of start seeing where that telemetry is coming from. So I've got data that's coming in every 15 minutes because that's what the devices themselves poll at. Every 15 minutes, they go and they check to see, okay, how many cups of cakes were sold, what's my temperature, things like that. And then they send that data to IoT Central. Well, then what I've done is I've written a small query here that will allow me to continuously run and gather that data and output it somewhere. And I'll show you what that looks like. It's really simple. Anyone familiar with SQL is going to kind of recognize this. I've got an input source. My input source here is actually that event hub. So it's that big, industrial strength event managing portion of things. It's grabbing that data. It's pulling it off here, and I'm doing a query against it, and then I'm pushing it out. And so here's what the actual data from the event hub looks like. You can see down here that I've got my device ID, so I could split it up if I needed to. I've got my, what my temperature ID looks like, my in-queue time, and then I've got this big guy here called telemetry. Well, I actually want to see this data in other ways. So for doing that, I write this query where I basically say, hey, select telemetry dot, and then cake inventory filled, or inventory purchased, or location latitude, or one of those, and then I'm going to output that, right? And so I can run this test query and just see what this looks like. And you'll see now I've got a much cleaner version, right? So I'm not collecting all of those things I don't need, because really one of the things I care about is just the telemetry. Now, what I can do with that from an analysis standpoint is I can come over here and I can actually, hook this up to Power BI. And so one of my users that's never in IoT Central and maybe never even in the data systems, who pretty much just has to kind of monitor and see where this stuff is at, can get this real-time feedback view of what's happening. So every 15 minutes when new data is going to come in, this is going to be basically updated in some way. Now I could do this by device if I needed to, or I could, and like in this particular case, I'm kind of rolling it all up into one thing. But the capabilities here of being able to grab that real-time streaming data and doing things with it really opens up a lot of possibilities from a user standpoint that needs to be able to see, where we're at on things.
Well, once
So
it's in Power BI, you can then combine data sources as well. So you can take your Event Hub data and tie it to other data. So if you say are manufacturer, you could take your Event Hub data that's coming in that's tied to Power BI and tie that to, say, your shipping department data, or maybe scales for, for weighing things. So if you know these products are coming in and they're getting made, you could look at the outputs over here. Or if you're doing water quality, you can look at input, and you can look at, say your invoices of consumed cleaning agents, or, just, and be able to make, richer, have a richer conversation, because you can look at actual telemetry
yeah.
and then compare that with other completely different data sets that are relevant.
And so if I were, so if this were, like if we were to take this sample company to, to its logical levels, I could see here where I'm getting like inventory purchase. I can see that in real time. And I could build up a whole nother data set that basically shows me per machine what my sales are, and would help me to forecast, what do I need to do for purchasing. And so once I've done that analysis and I've kind of got it, figured out, and I've got it in code, I could then take that same purchasing type, logic, and I could actually move it, down further. I could move it to here. And if I wanted to, I could create a function and integrate a function into this that was basically like notify purchasing to order more flour, or order more, eggs, or, whatever is basically sort of needed in that down the line process. So this is really taking advantage of the whole concept of things and insights and actions, right? So you've got to have the tools to be able to build up, and you have to have the tools to gather the data, right? And so that's our devices out there, and that's our smart vending machine that's gathering that data and that's sending it out to the cloud. And then I'm jumping in here from an analysis and a business standpoint saying, okay, how can I make the most of this data that I'm getting? And then from an action standpoint, I'm saying, okay, I'm going to now just tie this into my inventory, so I don't have to necessarily order inventory. I can actually have the machine tell me when it's about to run out of, cupcakes, and have that inventory basically set up and ready to go. So that's, from a standpoint, there's a lot of possibilities, and a lot of opportunities, I think, for businesses, small businesses, medium-sized businesses, and of course those very large organizations to take advantage of IoT. And and Microsoft, I think, has done a really excellent job of sort of right sizing these products. There's the IoT suite of tools, which is good for the larger, enterprise, or even smaller. It doesn't necessarily have to be big. Just where the level of technical competency is a little bit higher, and people want to jump in and do things themselves. They want to create a bespoke application, and then there is, of course, like IoT Central, which is a lot of this stuff is handled for you and makes that transition and that step into IoT, pretty easy. So, Josh, do we have any questions?
We do. We have a bunch of them. Got a good bunch of questions. Connor or Sam, which one do you guys want to ask away? 'Cause I see we got some through the chat, but I don't know if you guys got others in a different channel.
Yeah, all of them are in the chat. If you think you can go quicker going through them yourself, feel free to do so, or I can begin reading some off for you.
So I'll just start at the top here. Now, how do you address security concerns with a Raspberry Pi? That's a great question. The thing is that these are fundamentally these are computers. They're running Linux or Windows, depending on how you configured them. So they need the same level of physical and network security that you would apply to any networked device that you have. So if you're putting this out in the field, you need to put it in a lockbox that is appropriately hardened and so on. Now, from a security perspective, as far as like, is there a vector for attacking your organization? These things are only going to talk to Azure, and they're only going to talk to Azure in a write perspective, generally speaking. So obviously, you could give the little container that's running the IoT Edge software. You could give it more permissions to say run a function app or something, but it's going to be limited to the amount of functionality you grant that application. And then, so theoretically, from a hacking perspective, you've got to physically find the device, you've got to crack it open, you've got to plug in the appropriate tools. Now, depending on how you build it, you could make it run headless. You could turn off its USB ports.
Yeah.
So then the best they could do is maybe abscond with your SD card that's got your OS in it, and I guess it could be a risk there. But they're talking about malicious action based on access to the physical device. So you're at the same kind of level of risk as, say, the traffic light control hardware, right? So
Yeah, and there are, so there are obviously in conditions where you think, hey, this device could be tampered with by malicious actors. There are devices that are built to be locked down, that you can't get access to the internal structure of it, and without really damaging the device to do it.
I believe
But
there's
one of
one
the
device that actually fries the device. So it actually
yes,
has tamper controls on the device. So if you like open the case, it
it's
like
shot.
basically fries it.
Yeah,
So yeah, you can physically secure them depending on the level of risk, depending on the type of data. And then from a network security perspective, it is about what is your container application doing, because the only rights it's going to have and the only access it's going to have are those that you give the container that's running inside the device. And then if
it,
you find that device is compromised, you can nuke it from your environment very,
yeah.
very quickly.
Directly from IoT Hub. And as a matter of fact, IoT Hub actually does include a number of tools and security tools that you can run basically a security agent down on your IoT Edge device. And you can set up for things that are that look for tampering. And from a security standpoint, if you do follow basically creating a certificate and using a certificate authority, you can use that certificate on that device itself. So someone can't necessarily come along and try and replicate your device or take your code, your SD card out of that and try and put it on another Raspberry Pi and hack it and try and use it to pretend that it's you or your company, because it won't have that certificate in place.
Yeah. Next question is, are digital twins being used in the biomedical space, robotics, or military?
I would say yes. So I do know, so from the biomedical space, meaning like, are we making digital twins of people? That we kind of do, like, that's done with MRIs and it's done with other data like that. And
Well,
so
we
in
do
a
with
way,
protein folding as well. The whole concept of protein folding and then comparing how proteins interact. That's all digital twin of
all
molecules,
digital
right?
twins basically. Yeah, so I think it is like, and are there plenty of opportunities to expand in that space? Yeah, I really foresee medical and IoT in the medical world is going to just basically, I think, boom in the next 5 to 10 years, especially with 5G rolling out, and that capability of being able to get a lot more devices in a much smaller space is going to be a big boon to hospitals.
Yeah, from robotics and military, I can't see there's got to be, but just not directly related. But there's a concept of generative engineering, where you create a series of constraints, define a material, and then say, let the AI solve the question of what is the right shape for the material to meet the constraints. I have a load here, and I want to use aluminum. Tell me the shape of the aluminum should be.
Yeah.
And
Well,
that's absolutely, it's a continuously running simulation of variations until it finds one that works, which is in a way a digital twin scenario. So I can't see that it's not. Yeah.
exactly. And the thing to keep in mind is, like, digital twins sort of originated in from NASA, right? So it's the idea was that we're going to basically build an entire replica, on Earth digitally of what's going on in space. In fact, the term digital twins, I do not remember the actual person from NASA who coined that term, but it was a term that was coined at NASA.
Next question, is there a limit to the number of IoT devices to be used in IoT Central?
That's a good question.
So I did some looking while you were demoing.
Yeah.
So IoT Central sits on top of IoT Hub. There is a cost per device after the first two. It's something ridiculously tiny. It's like tenths of a penny per device. IoT Hub allows up to 1 million devices per hub.
Right.
So what you pay for your consumable in IoT Central is the messages. So depending on the level, you get a certain number of thousands of messages per month, and then over that you have to pay for the additional messages. So the standard level 2, which is like their most premium version, is 30,000 messages, and then It's like a tenth of a penny per message after that, or something like that. So, but there is a nominal fee for each additional device, and it's devices per hour that you pay for. So you pay a nominal fee per hour the device is active. And I think the definition of active is sending a message. So if a device is shut down in the evening, it's not considered an active device.
And my recommendation would be that if you've got 1 million devices, you definitely need to use IoT Hub and not IoT Central. That would
So
be
Hub
my.
is underneath Hub is underneath Central. So if you decide to
It
pivot
is.
away from Central, the Hub data is still there.
Right. Yeah, you can definitely move. Well, you can, if you're continuing to export your data and everything, you know, you can definitely get all of your data out of IoT Central. But you know, sadly, it does actually require a shift. There's not a direct path of migrating from IoT Central to IoT Hub, but it's not a big deal to get your devices and everything set. So whatever devices you have that are, you know, plug and play and set for IoT Central, they're also going to work on IoT Hub, right? So you're going to have that same kind of capability. We have got like 4 minutes, so we probably need to close it down. Let me just quickly talk.
We got a couple more questions. Worst case scenario is send those questions. We'll capture them. If you want to give us our contact info, we'll reply specifically to your questions, because we don't want to leave you out.
And we did talk a little bit about, you know, an innovation workshop. That is absolutely, in my opinion, like the best way to figure out, hey, do I need to get into IoT? Like, is it the right solution for me? We would love to talk to you and help you on that journey. And of course, you know, we want to know, how good did we do today? Did you enjoy this? Was it terrible? Was there information we left off that you really wanted to hear about? Please take our survey. Let us know. There is a possibility that you could win an Amazon gift card for doing that. So we appreciate your time. I'm gonna, you know, and Josh, thank you very much for doing this with me.
Pleasure.
This was great. It was a lot of fun. And so I'm gonna let everybody go.